Okay, so in space physics, the first idea is related to the Earth. So there are many things that we already know about the Earth, but according to the syllabus overview for the space physics, the first idea about the Earth is Earth orbits around the Sun, and secondly, we all know that the time period to orbit around the Sun or the number of days in 1 year is equals to 365 days. So this is like approximate or an average number that we used to write for 1 year, that is 365 days. But if we want to write more approximate value, so this is around 365 days, 6 hours, 9 minutes approximately. It is also not confirmed, but this is only approximate just for your information. But we know that in calculation or in numbers, we will always write 365. And one more important thing, in diagrams or in the pictures or in the books, we got like circular orbit of the Earth. But we all know that the orbit of the planets are not circular. Same for the Earth. The orbit of the Earth is elliptical, right? And in diagram, there is elliptical shape also. You can see what is the difference in the elliptical shape. Let's suppose if Earth is on this point. So this point is close to the center. Like the vertical
Sir,
distance,
could
if
you
you measure.
define elliptical?
Elliptical, like in simple words, like oval shape. This diagram is also elliptical form, right?
Right, okay.
So basically, this picture is for elliptical shape. So this is actually called elliptical. So in elliptical, you can see that this vertical upward point is close to the center, and same on the other side, vertical downward side. So vertical sides are close to the center, but if you consider the horizontal sides, so horizontal sides are at greater distance from the center. Okay. And same happens on the other point. So it is not like completely in a circular form that we used in our mind previously, like in lower grades, we studied that that is circular, but it is elliptical. And in elliptical, you can see some points are close to the sun. If we consider sun in the center, definitely we orbit around the sun, the whole earth. So at some point we are close to the sun, but at some point we are away from the sun. So this is the idea.
Okay, sir, could you write down?
Okay, so for elliptical, you can just simply write it is a slightly oval shaped path. So these are some important ideas about the orbit of the Earth, and definitely we got this concept that at some point we will get very close to the sun, but at some point we are slightly away from the sun. And in normal physics concept, we studied about journal, thermal, electrical, many types of physics concept. So we also know that when something is moving, so definitely there will be some speed of that body. Okay. So Earth is like orbiting around the sun. So definitely there will be some speed of that planet around the sun. So that is called orbital speed.
Mm. Oh, what does that mean?
Because we got already the time period. We know the Earth covers 365 days to cover one orbit around the sun. Okay, so we got the time. And if you remember the basic formula of speed or velocity, so the formula for speed and velocity is distance over time. So we know about the time, but we don't know about the distance, right? We didn't talk about that. So according to the concept of orbital speed, it is the average speed. We say that the average speed at which the Earth or like any other planet or body which orbits around the other body. And there is very simple example of this, the example of satellites. We use satellites to orbit around the Earth. So definitely those satellites are also moving with some specific speeds. So if we consider our planet also as a satellite, so these planets are also revolving or orbiting around the sun. So definitely they are moving with some speed. That's why it took 365 days for Earth to complete one complete round trip around the orbit of the sun. Okay. So we also use the term average speed because maybe according to the elliptical shape, there is also a concept of gravitational force because there is no direct physical link between sun and earth, right? Like there is no cable or no string is now connected because we are talking about now planets. So there is only a force of gravity. So with the help of gravity, the earth is orbiting around the sun. So when earth is slightly away from the sun, so you know that gravitational field will be slightly less. And when Earth is very close to the sun, so definitely the force of gravity of the sun on the Earth will be greater. Okay. And if we talk about the journal formula, so the journal formula for speed is distance over time. But let's suppose if you are talking about a circle, because we are taking elliptical almost like as a circle, because if we consider that elliptical, so it will be very like a typical way to solve the questions. So we are at like early stage, so that's why we are taking it like in a circular form. But time by time, when you got the idea, so we move on to the advanced steps. So if you want to find out the distance of the circle, like what is the total length of that circle, so what we calculate? We calculate the circumference, right? So the orbital speed can be find out with the help of circumference divided by the time period.
Orbital time.
Yes.
Oh my gosh, math and physics.
Okay, let's suppose if you consider this is very like
I have one question.
yes,
How can you use the circumference of a circle if the orbit is, what do you call it, elliptical?
yes. Basically, we consider that one almost as circle, right? You know that in your books, in your diagrams, they are in a circular form, right? But originally it is elliptical. So we consider that one as circle. That's why in definition it is written average speed. We know at some point there will be greater gravitational force. There will be somewhere it will be less. So the number of days are also approximate. The speed is also average. These are not like absolute values. Okay. So just for to
Okay.
understand the idea, we will start with circular concept, right? And when you want to study about the advanced, so you will find advanced applications related to elliptical shape also, right?
All right, sir.
So at initial stage, we take it as a circular. And we know the idea of the circumference. Like if you consider a very simple example, the example of your car. So speedometer easily shows your speed. So how speedometer measures our speed? So very simple. It counts the revolution per second of the tire. That how many times the tire rotates or complete one cycle. So that is also called circumference. So that speedometer also works on the principle of this circumference idea. Like if you have a circular disc and if you mark one point on it, and this is the rotation. So when this point rotates clockwise and again it reaches the same position, so that is called one complete circumference, right? Because circumference is the total length of this circle. So you just started from the same point and again you just reach the same point, so that will give you the idea of one complete orbit. So that is called the circumference of the circle or the length of the orbit. So this is circumference of circle, or for space physics we can take it as length of an orbit. And this capital T represents the time taken for one complete orbit around the sun. So time taken for one orbit. So any confusion till now in any concept related to this? We started with the Earth. We talk about the number of days. We consider one important idea that orbit of Earth is elliptical. Then we discuss about orbital speed. And in orbital speed, we use the average concept, right? Not the absolute speed. We use the idea of average speed because we are taking circle length of the path, that is the circumference of a circle. So these are the initial points related to the Earth. Okay. Okay. So if you have no question, there is one more important thing about the Earth. Basically, these are very to the point things. Basically, they will not ask about the explanation in exam that to explain for 3 marks, for 4 marks. I will also tell you because in past papers, if you just go through the past papers, so you will find mostly questions are related to red shift, blue shift, or there is one more idea which is called formation of the star, stability of the star. So those are very detailed topic. These are like basic ideas for the Earth. Because first you need to know about your planet, which is Earth, and then we have to consider some other planets also, because we are applying the same theory on those planets. And there is one more idea about the Earth. Just like we draw a normal in light chapter, we draw normal to measure the angle. So let's suppose if you consider a round sphere, complete proper circle. So if you just draw a straight line in the middle, so that will be like this. Okay, completely in the center, straight line, and this is called axis. Just like in our car or in our bikes or in our bicycle, there is a axle which is in the center, and around that the wheel rotates. Also, the example of the fan, there is a center axis or the axle connected in the center. Fan rotates around that axis. So there is one more important theory about the Earth, that the axis of the Earth is not completely at 90-degree, right? Not very straight perpendicular. It is about 235 degrees from the center. Okay. So it means that the axis of the Earth is not straight. It is almost equal to tilted at 23.5 degrees, right? So this is one more information about the Earth, that is the axis of Earth is tilted 23.5 degrees if we measure from vertical. Okay. So this is one more fact about the axis of the Earth. It is not vertical. It is around 23.5 degrees from the vertical. Okay. And that's why in the second figure, in figure number 2, you can see all axes are tilted at 23.5 degrees almost, right? Like this one, this one. So all are tilted at 3.5 degree almost. No one is completely vertical. And why this is 23.5? There is like logical reason given by the science that why there is 23.5-degree angle tilted from the vertical. Now let's suppose if we consider different phases of the earth around the sun, because we consider elliptical shape. Now this figure number 2 shows you elliptical shape. This is not circle, this is elliptical. So if we start from the top one, like March 21st. So in March 21st, you can see that this is your axis of the earth. And according to this axis, uh, half of the earth is facing towards the sun. Okay. And the opposite side is not facing the sun. So half of the earth is facing sun, but half of the earth is not facing sun. So it means that around 21st March, the length of one day and one night is almost equal. So day and night of equal length. Because we identify from this elliptical shape and this tilted axis. You can see in the first case, let's suppose this is the first one, that half part of the earth is facing, and we are talking about this March 21st. Now, if we continue to move on the next one, so the next part is for the spring season, and we are talking about June 21st. So normally in June, there is summer season. So now what happens? Again, we use the tilted axis over here. So there is one more change in this position. You can see this distance is increased. You can measure this length and the first length. So the second length is greater than the first because of elliptical shape. So the first change we observe that the distance is increased as compared to the first position. So this is the first change, right? And the part which is highlighted, so that part is facing the sun actually. So we are getting summer season over here. And in summer season, we know the length of the day is actually increased and the length of night will decrease. So we have longest
Yeah,
day
like
in
we
this.
have longer day in the summers and like
Yeah.
shorter day.
Yes, so we got longer days in summer, okay, and shorter length of night because due to this elliptical shape, right? So the distance is actually increased. So Earth will take more time to travel this distance, right? As compared to the first one. That's why we use the concept of average speed because at some distance, Earth travels very quickly, but at the some distance, Earth travels slowly because of elliptical shape. It has to cover a long distance, right? Then in the third position, the third position is actually the opposite of the first one. Again, we have same length of day and same length of night. So day and night of equal length. And the last part, part number 4, again, we have elliptical shape, long distance. Now we are talking about December 22. So now in December 22, the season is now changing. We are almost at winter season over here. Okay, so basically we highlighted two parts of the earth. So why we highlighted them? So the reason is very simple. If you consider those highlighted shape, so if you compare this shape with this one, so you feel there is one difference. This highlighted part is facing forward towards the sun, right? This is facing forward. Okay, and we highlighted this part. Let's suppose we are living on this part of the earth, okay, the highlighted part. We are in the region of this highlighted part. So on one side of elliptical shape, we are facing forward towards the sun, okay, and now when we move on the other side, so we are facing away from the sun, right? Because you can see this tilted shape is away from the sun, the face is away from the sun. This is facing away. So that's why, because if we use the same idea, so on both sides we will get summer season. So how we will get winter season? So the concept is very simple that we use the highlighted part, and due to this highlighted part, on one side we are facing towards the sun. So on our specific region we have summer season, and when we move on the opposite side, so there will be winter season. And same happens with the rest of the part of the earth. Okay. Clear? Any confusion?
No, sir.
Okay. And we will also get the longest like night in the winter and the shortest daytime. Minimum daylight hour.